Professional photo editing has reached a point where a few text prompts and a single click can completely relight a scene or generate entirely new background elements. The appeal for creators is obvious. It saves hours of tedious manual labor. But accessing that level of automation usually comes with two major strings attached. First, you are locked into a recurring monthly fee. Second, to get those instant results, you have to upload your high-resolution, often sensitive client files to an external cloud server. There is a way to get professional-grade artificial intelligence manipulation without the paywall or the privacy risk. It lives entirely offline, on your own hardware, inside the open-source image editor, GIMP. Using a specific set of community-built plugins, you can run advanced tasks right from your desktop. We're talking automated subject masking, intelligent noise reduction, generating missing textures, and increasing resolution without losing quality. This matrix compares premium cloud suites against GIMP with AI plugins across cost, data privacy, and setup efficiency. The open-source route zeroes out your financial cost and keeps data entirely private. However, you pay for that freedom with a severe drop in one-click efficiency. You aren't downloading software that handles everything automatically. You're building a custom machine. You have to actively source, download, and configure distinct tools tailored to the specific problems you need to solve. To master this ecosystem, you are making a direct trade. You keep your money, and in exchange, you spend your time assembling and maintaining a personalized offline workflow. Let's look at how this assembly works in practice, starting with one of the most notoriously tedious jobs in photo editing, cutting a complex subject out from its background. Trying to do this by hand using standard selection tools is a massive drain on time. It is especially punishing when you encounter fuzzy, semi-transparent edges, like hair or fur, where a manual lasso line is practically useless. To solve this, you need to install an add-on called GIMP ML. This is a toolkit built on Python, a popular programming language, which brings deep learning capabilities directly into the editor. Specifically, GIMP ML includes a background removal tool powered by an algorithm called U²net. Instead of tracing pixels manually, this model analyzes the image, identifies the primary subject, and automatically generates a mask around it. This flowchart shows the workflow. Snap this masking module onto your standard editor and route a raw photo through to isolate your subject. But looking closely at the boundary, the automated pass leaves behind a jagged, pixelated artifact known as edge chatter. Fixing this requires a quick, manual intervention. You take the generated mask, expand the selection by exactly 1 pixel, and then apply a 1-pixel feathering effect to soften the transition. That extra step adds a tiny bit of friction to the process, but performing a 2-second adjustment to smooth out an automated mask is a massive improvement over spending 20 minutes painstakingly tracing a subject by hand. Once your subject is isolated, you often need to clean up the rest of the frame. That means erasing stray background objects, healing scuff marks, or repairing deep scratches in vintage scans. For this, you snap on a plugin called Resynthesizer. This operates as the free, entirely offline equivalent to the content-aware fill features found in expensive commercial software. When you highlight a damaged area, Resynthesizer mathematically analyzes the healthy pixels surrounding your selection and then generates matching textures to seamlessly patch the gap. You pair that with a massive extension called GMIC. GMIC is an open-source framework containing over 500 processing tools, which gives you precise, guided control over heavy noise reduction and detail sharpening. Returning to our workflow map, we layer these modules to take a scratched source file and output a clean image. However, lazily filling a massive chunk of the image all at once breaks the math, outputting an unnatural, repeating pattern of cloned pixels. To prevent those seams, you have to operate with discipline. You isolate small, overlapping patches one by one and slightly alter the mathematical seed settings to break up visual patterns. These modules provide elite-level, localized restoration capabilities, but they demand a patient, surgical approach. They are precision instruments, not blunt tools. Even with a perfectly clean image, you might still face a physical limitation, a source file that is simply too small. If you stretch a low-resolution image, you introduce heavy pixelation and blocky artifacts. To fix this, we rely on external neural networks. Tools like Waifu2x are trained specifically to scale up digital illustration and line art, while real ESRGN excels at hallucinating missing details in general photographic textures. To use these upscalers efficiently, you export the file out of the main editor and run it through a standalone application before bringing it back. While breaking that single window experience feels clunky, running models externally frees up system memory, processing the image significantly faster. That speed becomes critical when you transition from editing a single photograph to processing hundreds of product images for an e-commerce catalog. By combining saved parameter presets inside GMEC with a simple Python script, you can automate this entire chain. The software will open a folder, run the background removal, apply the noise reduction, and export every single file without you clicking a single button. To prevent the script from breaking mid-run, you must enforce absolute order on your hard drive. That means standardizing your file naming conventions and maintaining a clean spreadsheet of exact file paths. Stepping outside the comfortable graphical interface and writing a few lines of code is a steep requirement, but that initial setup time buys you automated, repeatable consistency across massive libraries of images. You now know the pieces available to you, but installing all of them at once will leave you with a bloated, unstable setup that crashes frequently. The goal is to construct a lean machine by matching only the specific modules you actually need to your daily editing realities. This scorecard maps out 3 distinct user profiles to show how different needs dictate different configurations. First is the e-commerce catalog manager. They have zero budget and hundreds of products to process. They absolutely must install GIMP ML and GMEC. The hours they save by automating background removal and noise reduction heavily outweigh the painful initial setup process. Next is the privacy-focused professional, handling unreleased product shots or sensitive client portraits. They must adopt the entire offline stack, including the external upscalers, to guarantee that no proprietary data ever touches a third-party server. Finally, there is the casual user who just wants to remove a blemish for a social media post. They should reject this modular ecosystem entirely. For them, wrestling with Python dependencies and plugin folders is a terrible return on investment. But if you do build one of these automated workflows, there are strict operational rules you have to follow, regardless of your profile. You are required to check the repository licenses for the specific machine learning models you download to ensure they permit commercial use. And if you are radically altering a photo, especially for a client, you need to clearly disclose those automated steps. There is also a severe visual trap here. These algorithms are aggressive. If you let them run at full strength, they strip away all natural imperfections, leaving you with an unnerving, plastic-looking image. You counter this by applying the 10% rule. After you run a heavy noise reduction or repair pass, you actively dial back the opacity of that layer to let a small amount of the original human texture bleed back through. The human eye forgives a little bit of noise. It does not forgive plastic. The open-source AI ecosystem offers elite capability. It proves that total creative control and absolute data privacy do not have to come with a monthly fee, as long as you are willing to embrace the friction of building the machine yourself.